Hello friends, this video on alcohol, phenol and ether part 19 is brought to you by examfear.com. No more fear from exam. So glycerols are nothing but they have 3 OH group, and please note that they are adjacent. Right? If you see this carbon, this carbon, this carbon, they are 3 adjacent carbon and they have 3 OH groups in the adjacent carbon. Correct? They are there in almost all animals and vegetables, oils and fats. They are always there. And they are formed by the reaction between glycerol and carboxylic acids. So if you see, I have glycerol, which we have discussed in the last slides. I have carboxylic acid, of higher molar mass. Actually, we take generally high molar mass, and you get glycerides. Correct. Now we have this glycerol. From this we are forming glycerides. Correct. And these glycerides, if you see, are nothing but my esters. So we learned glycol, we learned glycerol, and from glycerol we are trying to prepare glyceride. So there are 3 different things. Please note. Glycol, it has 2H. Then glycerol, it has, see, the name is, the length is more, that means it has more OH, right? So this is 3 OH, this is 6 character, this is how much? 8, 3 OH, and then we have glycerides that is prepared from glycerol and carboxylic acids. They are esters. We'll discuss about this. In fact, I can give you an example of glycerides. Example, CH2O COR1, some R2, some R3. So this is example of glyceride. Correct. Let's see the preparation of glycerol from fats and oils. So it's pretty simple actually. You have fat, you take NaOH, and you get glycerol, and you get sodium salt of fatty acid. Sodium salt of fatty acid. This is the typical reaction, right? I'll take them fat. Fat is nothing but my glyceride. CH2O COOR1, CHO COR2, correct. You add NaOH in huge quantity, in this 3 NaOH required, you get CH2OH, CHOH, CH2, and this is my glycerol. And what you get, R1CONA, R2CONA, R3CONA, like that. R1CONA, similar, this R2, you'll get R2CONA, and R3 also you'll get CONA. Correct? The sodium salts of fatty acids. In fact, there are other ways also to prepare glycerol from fats. So you can take this fat and you can take this super hot steam. Super hot steam if you take and have some pressure, you use dilutic sulfuric acid in some pressure, good amount of pressure, you get glycerol. For example, CH2, this is my glyceride of fat. Okay, let me write this glyceride of fat. Now on this, what I do is I add the super hot water, right? Super hot water and all this sulfuric acid and pressure, I get CH2OH, CHOH, CH2OH, and you get R1COH, R2COH, and R3 That's what you get. In fact, they are different products. Correct? This is my glycerol. There is one more third way to prepare glycerol from fat. You take fat and you take methanol, right? You take some acid or base, whatever you want, and you get glycerol. Example I can give you. I have CH2O, COOR, let everything be R actually. Yeah. Now on this you add methanol, some acid or base, I don't care. You get CH2OH, CHOH and CH2OH. Plus you also get R, COO, CH3. You'll get 3 for this side. So this is one other way to prepare glycerol from fats or oil. Now we'll prepare glycerol from propene. So propene is a byproduct from the cracking of petroleum. So we'll use that to prepare glycerol. This is used in industry. So I have propene. So what we do is generally we react with chlorine at a high temperature. So what happens is this becomes CH2Cl, CH double bond CH2. On this you add Na2CO3. So this becomes CH2OH, CH double bond CH2. On this you add HOCl. You get CH2OH, CHOH and CH2Cl actually, yeah. And on this you can add NaOH to replace this chlorine with OH. So what you get is CH2OH, CHOH and CH2OH. And this is my glycerol. So we studied the physical properties. They are liquid, if you see. They are colorless, almost, right? They are syrupy. They are sweetish in smell, taste. They are hygroscopic. They absorb water, and they are water, alcohol, and acetone soluble. But they are insoluble in ether. Please note, the other one was soluble only in water and insoluble in other organic compound. But this is water, alcohol, and acetone soluble, but insoluble in ether. And it boils at 563 Kelvin. We'll talk about some chemical properties of glycerol now. We'll take some reaction with sodium, reaction with HCl, reaction with Hi, reaction with HNO3, reaction with acetic acid, reaction with oxalic acid, oxidation and dehydration. We'll talk about these many reactions about glycerol, but we'll not talk about the reaction mechanism for most of these. We'll just talk about the reactions. Now we'll talk about the reaction with sodium. For sodium, if you see, I have CH2OH, CHOH and CH2OH. This is my glycerol. When it reacts with sodium, this H is replaced with Na. So this becomes ONa, CHOH and CH2OH. You add more sodium, then this H will be replaced with Na. The reaction keeps happening. Correct? So let's see the reaction with HCl. Similar reaction actually. So what we have seen, but if you see here, there is a small difference here. I have CH2OH, CHOH, CH2OH. Then react with HCl, you get a mixture of product actually. In one case, this chlorine is replaced, one case this hydrogen is replaced, actually OH is replaced. So I'll show you, it will be the product mixture. Does become CH2Cl. The first OH is replaced. In another case, this middle guy is replaced, OH. So it's a mixture. Correct. Similarly, we'll see the reaction with HI. Actually, glycerol is reduced by HI. It is reduced by HI. Here it is my glycerol. Right, I will show the reaction. CH2OH, I have CHOH, I have CH2OH. When I react with HI, it reduces and you remove water from head. You get CH2, double bond CH, CH2I. That's the reaction is. You add more HI, it's a little funny now. So this becomes CH3, CH, double bond CH2. Right? You add more HI here. So this becomes CH3, CHI, and this becomes CH3. That's how the reaction is with HI. Little weird reaction. Now we'll see the reaction with HNO3. I have CH2OH, I have CHOH, I have CH2OH. React with HNO3 with some sulfuric acid, because that is something which will make NO2 ions. So this will become CH2ONO2, CHONO2, CH2ONO2. If you want, you can guess the mechanism. Actually, HNO3, when this reacts with this, you have seen this, right? And this guy is the one which attacks and kicks out all the hydrogens from this. Now we'll see the reaction with acetic acid. So with acetic acid, it forms ester. It forms ester. I'll show you one example. I have CH2OH, CHOH, one glycerol I react with CH3, COH. What I get is CH2O, COCH3. Actually, this H and this OH reacts. And similarly here also, if you see CH, OH and CH2OH. If you keep reacting it, you keep reacting again with the CH3COH. Now again, what will happen is this last one will be converted. So this will be CH2O, CH3, CHOH, and this will be CH2O, COCH3. You add furthermore acetic acid, the remaining one will also be changed now. It will become CH3O, COCH3, CHO, COCH3, and CH2O, COCH3. This is the reaction mechanism actually. Okay. Now we'll see the reaction with oxalic acid. So I have this glycerol, and when I react this with oxalic acid at a high temperature, maybe 400 Kelvin, water is lost, and what you get is CH2O. This is the compound you get. Correct. Now if you heat this guy, carbon dioxide is lost from here. So you get H2O, COH, CHOH, and CH2OH. This carbon dioxide is lost actually. Wait, when you heat this. Correct. And this you can do hydrolysis and get back the glycerol. So you're back to the same circle. We'll do oxidation of glycerol actually. So here also we have seen oxidation and reduction. Generally it depends on the agent we use. Here also different product based on the agent, right? I'll not take deep into this. I'll just explain you overall thing, different product based on reagent. So This is my glycerol. Correct. So if I take HNO3, dilute nitric acid, what I get is glyceric acid. If I take, this is dilute. If I take concentrated nitric acid, which is strong, I get glyceric acid, but with that, something is extra. That is tartaric acid. And if I take KMnO4 in this acidified KMnO4, what you get is carbon dioxide and oxalic acid. So you see different products based on the different oxygen. Correct. So let's see the dehydration. So I have a glycerol and I heat this and add some agent, for example phosphorus pentoxide. What you get is acrolein, and it has a very bad smell. Very bad smell. So I'll show you the reaction. This is my glycerol. Right? So if you heat this with, let's suppose, KHSO4, so 2 H2O is gone. One from here, one from here. And what you get is CH2 double bond C double bond CHOH. It's unstable actually, right? And from this, what will happen is this H will jump here, and you get CH double bond CH2 COH, and this is my acrolein, and this is a foul smelling acrolein. Let's understand some uses of glycerol. It is used for cosmetics, it is used for textiles processing, it is used to preserve fruits, it is used for sweetening agents, it is used to make medicines, mostly the cough syrups. It is used to manufacture explosives, and it is also used for antifreeze in motor car radiators. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.